Have you ever gone to a heat pump and asked yourself, what am I looking at? You see all this copper tubing, copper lines going everywhere, and it looks intimidating, but it doesn't have to be. I hope by the end of this video, you have a basic understanding of how heat pumps work. Okay, so I'll be moving around the camera so you get to see all the parts to a heat pump. But let's just go over real quick the refrigeration cycle. You have your compressor, your condenser, your evaporator, and your metering device. You need those, at least those four things to have a refrigeration cycle, a functioning refrigeration cycle. So we have our compressor, right? We have our metering device. We have the indoor coil here, right? And for a heat pump, we're going to refer to as the outdoor coil and then the indoor coil, the one inside of the house. And then in there, we can confirm that's the indoor coil. So, you know you're working on a heat pump if you have a reversing valve like that and two metering devices. A heat pump has two metering devices. But just going back to this reversing valve here, you have a couple of things we want to just kind of point out here. This bottom line here, the bottom one right here, and you can see it's kind of the one by itself, right? By itself here. Lonely. It's lonely, but it's powerful. And why do we say that? This is my discharge line. I have high pressure, high temperature vapor. And how can we confirm that? We'll follow the line. Follow it with me, follow it with me, follow it with me, and goes right there. It's coming out from the compressor. So it's my discharge line. The middle one is my true suction. And we call it the true suction because it never changes. It's always my suction. And how can we confirm that? Well, we follow it, right? It does this little U like that. It comes down here. And then it kind of curves that way. And then you see it kind of go up, and then it goes in there to the compressor. So that's my suction. That one never changes. That's my suction all the time. So let's say we're in cooling mode. So how does the cooling mode work? Well, follow with me. We have this high pressure, high temperature vapor on the discharge line. If I am in cooling, I have to first reject that heat outside so I can get liquid coming back in. I'll repeat that. If I'm in cooling, I have to reject the heat, right? I have to reject the heat on the outer coil, and that in cooling, the outer coil is my condenser, so I can come back as subcooled liquid. So if you follow with me, which course is it gonna take? Well, it's gonna take this course here, this flow, because if you follow it, it is going up here. It's going all the way up here to my condenser, and over here, and I know you probably can see it. You see the line inside there? You actually see that kind of coming out, going here, and then it goes to my condenser. You can see all the little circuits here. It goes to my condenser, and then you might not be able to see, but let me see if I get a better view. You see all those little lines there? Distribution lines. They all come after it turns into a liquid. They all come down. They all come down. They all come down to this line right here. So let's go back to that right here. It goes up as I have high pressure, high temperature vapor. It goes to my condenser, rejects heat, and then it comes back to my to this liquid line here. And this is subcooled liquid. But the crazy part is that in there, you actually have a metering device. And it's this one here. This one goes to that metering device. There's a TXV in there. But when it's flowing downward, it's just flow. It is just a flow because we're not flowing up. And you'll be able to see it with this other example. But heat pumps have two metering devices. But just kind of going back to the basics, right? High pressure, high temperature vapor going up, goes to the condenser, rejects heat, coming down as subcooled liquid. As I go through this metering device, if I'm flowing this way to the left, It's just flow. You could just even imagine the metering device not being there. It's just going this way. It's just flow. When it goes this way, it meters the refrigerant. It drops in pressure, dropping it in temperature. It meters it. It acts as a metering device. But when it goes this way, it's just flow. Just flow. So it's just flow. It's just flowing through. And it goes through this a bi-directional filter dryer, and you can confirm it because you have arrows that are back and forth. The thing with the heat pump, in cooling, it travels this way, and heating, it travels the other way. But we're in cooling right now, right? So let's not get, I'm not gonna get ahead of myself here. So come in here, it's just flow. Boom, boom, boom. And look, now it goes to that metering device. And this is not flow because it's going this way, it's gonna drop in pressure. And we can see it. It's gonna drop in pressure. You get saturated refrigerant going to my indoor coil, right? So now I get some cooling. Now I have low pressure, low temperature vapor coming back. And if you follow it, it's coming back, it's coming back here. And we did say that initially for cooling, my high pressure, high temperature vapor was going this way. So if it's coming this way, whatever two are left, right? Because it's going that way, whatever two are left, you basically have a U right here. So it's going like this, making a U, coming back to my true suction, going back to the compressor. In heating, is almost the same thing. It's just that it's going in a different direction. So instead of that high pressure, high temperature vapor coming down here and going this way, the reversing valve, the little slider, and I'll show you a reversing valve in action. It pushes this way. So now these two have a path. That high pressure, high temperature vapor now goes this way. Boom, it goes this way, this way, this way. And look where it's going to my indoor coil. Now, when I'm in heating, my indoor coil is my condenser. I'm rejecting all that heat inside of the house. I'm supplying hot air into the house. I'm heating the house. And that makes sense. I'm rejecting the heat inside of the house. So I have all that high pressure, high temperature vapor going into the house. And look where it comes back. You have all these lines here, distribution lines coming back, and it's going through this metering device. But as I had mentioned, when I was in cooling, when I was going that way, it metered it. But guess what? When it comes this way, it's just flow. It is just flowing. I am not dropping in pressure. I am just flowing because I'm going this way from the right to the left. So it's flowing, it's flowing, it's flowing, it's going, it's going. And boom, once I hit this metering device, this one meters it. This one drops it in pressure. Now I get saturated refrigerant. And that makes sense because my indoor coil was the condenser. My outdoor coil is my evaporator. So I got saturated refrigerant going in there. And I have it going through all these lines right here, distribution lines in there, going to my outdoor coil, my evaporator, absorbing heat from the outside air, and then coming back as low pressure, low temperature vapor. And if you follow this line, now it's coming down. If you recall, when I was cooling, it was going up. But now that I'm heating, it's coming down as a low pressure, low temperature vapor. And it's coming down. And it goes through this little U, because we did say when I'm in heating, the high pressure, high temperature vapor is going on that line. So these two share a little U. And it goes to my true suction back to the compressor. So this is a closer look up of a reversing valve, and you have a couple of things. You have this slider that moves, right? This slider, and then you have your little coil here, solenoid coil, and it's just a coil. That's all there is to this, and hardly these ever go bad. I'm not saying they don't, but they hardly go bad. But if you ever wanted to test it, you can just simply go to one end and go to the other one. Think about a contactor coil, kind of the same concept. It really is the same concept. And then you see I'm getting 13.43. The coil's good. But like I said, yeah, we have a couple of components here. But just going back to this, just keeping it basic, you have the slider. So if I am in heating, right, at least with the example we just went over, if I am in heating, the slider goes that way. These two share a path, and then the high pressure, high temperature vapor goes through this line, going to my indoor coil. If I am in cooling, boom, it goes this way. Now these two share a path, and the high pressure, high temperature vapor now goes to my outdoor coil, my condenser. Now, the way this works, you have some lines in here. You got this little line right here. You got 1, 2, 3. So you get this high pressure, high temperature vapor. This high pressure, high temperature vapor, it's either going to go to this side or that side. You can think about this little pilot valve in here as a little mini reversing valve. So let's say we have our coil, but I took it out just so you could see it, and I might have to take it out, but okay, we don't have to take it out. You could see it. You can see you have 4 lines, right? 1, 2, 3, 4. So you see one's coming from my discharge line, my high pressure, high temperature vapor. The middle one is my true suction. So at any given point, I'm gonna have this high vapor and then low vapor. The cool thing about the reversing valve is if I send high vapor on this side and low vapor over here, and actually we can turn it around so you can see what I'm talking about. Like I said, at any given point, either high vapor is here and low vapor is here, or high vapor is here and low vapor is here. But let's say in the back, high vapor is going in here, and then it's going inside, and then it's going to this side. And then the low vapor, low pressure, low temperature vapor is going here and going on that side, right? High vapor, low vapor. Where is this slider going to move to? It's going to move that way. High vapor pushing in, and you can see in there, you kind of have a little opening. You can actually see the little tubing in there where it comes out. High vapor goes in, boom, pushes it that way, and this is low vapor, right? Suction, high pressure. And the opposite works. If now the pilot valve, let's say I send 24 volts, to this, it basically changes the little reversing valve here. It changes direction. So instead of sending the high pressure, high temperature vapor that way, I'll send it this way, and then my suction or my low vapor goes that way. So if that's the case, if now I have high pressure, high temperature vapor going here, low pressure, low temperature vapor going here, right? High vapor, low vapor is going to push it that way now. And you can see I have a little opening there. Now, at times, the sliders do kind of get stuck. So sometimes just like say, for example, this is my suction line. So this is going to also be my low pressure, low temperature vapor right here, my suction. You can get a temperature clamp on both. They shouldn't be too far from each other in temperature. These two shouldn't be too far from temperature as well, because you don't want this to happen, kind of getting stuck halfway. Another thing too is that the system has to be on for you to have that differential in pressure. It has to be on, because if it's not on, it's static. There's no differential in pressure. There's no pressure difference. So if you're low on charge or the unit is not on, you won't be able to do the test to see if it's working or not. So yes, the unit has to have refrigerant. It needs to be on. So so this is simply it. This is simply how the reversing valve works. You're powering up this little coil, right? And by powering this up, it just basically moves the high pressure, high temperature. Like, let's say if I don't power this up, is default, maybe it's going this way, and then my suction is going that way. I power this up. Now it takes the high pressure, high temperature goes that way, because it moved down here inside. It goes that way, and my suction goes this side now. All right, welcome back to the jungle. And a lot of the times you have all this wire just staring at you, but like I said, we're just gonna keep it simple. So this is a heat pump. So we have the base here. We have this yellow one going to Y. So on a straight cooling system, not a heat pump, on a straight cooling system, that is true. By sending 24 volts to Y, I have cooling. But on a heat pump, we'll just refer to this as turning on the compressor. Okay? We'll turn on the compressor with Y. So then the fan goes to G, the red wire goes to power, blue goes to common, and the blue one can sometimes be brown for common. The O, reversing valve, I have a white. At times this can be orange as well. But right now, what I did, I have it jumpered. So I have the power and like I said, the compressor on. So on a straight cooling system, I would get cooling. But on a heat pump, it's a little bit different. Like let's go here. So we said the middle one's always my true suction. And I can kind of confirm that. I'm getting 58, 59 degrees. So where is that high pressure, high temperature vapor going to? Well, it should be going to my indoor coil. And we can confirm that by checking that. You see 85 degrees. So these two should be pretty much the same, which they are 55, 55, 54. But look at that one, 82 degrees. So this is warm. That high pressure, high temperature vapor is going inside the indoor coil. So when I check here, this is my return. Right, my return, I'm getting 56 degrees, but my supply, I am getting 89 degrees, 91 degrees. So I'm heating. I am heating. So this is what I want to get to though. This is the part I want to get to. Okay? So like I said, in a straight cooling system, if it's not a heat pump, if you send power to the Y, you're gonna have cooling. But on a heat pump, just to kind of emphasize the point, if you send power to the Y, it turns on it energizes the contactor and it's in heating. For me to get cooling, I gotta send 24 volts to my reversing valve. Right there, those two wires. So, like I said, my common on that side, it's already there. It's home run. My common's already there. I gotta send 24 volts here. And where does that 24 volts come from? Well, come from this orange wire right there. See, right there, orange wire. So I'm gonna send power from here to my orange one. But I'm gonna confirm we don't have 24 volts here. We should not have 24 volts. So let's go ahead and see it. Let's go down here, and you can see it on the meter. I'm gonna go ahead and test it, and I have 0 volts. You can see 0 volts going to that solenoid coil. But as soon as I go back here, and you're gonna hear it. Remember, the system has to have pressure. There has to be refrigerant for you to see that, to notice that, to get the reversing valve to shift. But I'm gonna go ahead and grab power from here. And then my orange one, that's the one feeding the 24 volts to my other side on the reversing valves, because we already said we already have common over there. Common goes home run. But this orange one, I'm going to go ahead and power this up. And you can kind of hear, I don't know if you heard it, but I heard it. You can actually hear the pressure now moving to a different direction. But I'm going to confirm it now. Do we have 24 volts going to that reversing valve now? I'm going to check it. There we go. We got 25.8 volts. And to confirm it, going back to this here, and heating, right? Because now we energize the reversing valve, at least before in heating, it was going to my indoor coil now. But look, now it's going to go this way to my outdoor coil. And I can confirm that. These two should be cold. My true suction, 56. Give it a second, 55, 52. So these are the same, 53, 52. But look at this one. That's getting warmer and warmer. We gotta give it a second because I just turned it on. It's gonna take a while, but I could just feel it. This is warmer. These two are cold. So now that I'm in cooling, it goes straight to the condenser, rejects heat, comes back as low pressure, low temperature vapor, and now it does a U between these two here, going to my true suction. But we can confirm though. We can confirm. This is my return now. Of course, we're cooling right now. You never want to turn on cooling when it's cold. A lot of the manufacturers, they say you got to be above 70 degrees inside of the house and 70 degrees outside of the house. But I'm just showing you that we are cooling. We got 52 degrees coming out on the return. And we have 30 degrees coming out on the supply. So yeah, we don't want to freeze that coil. But I just wanted you to see, by us energizing that orange wire, it sends 24 volts to the solenoid coil. My comment's already there, but it sends 24 volts on the other side of that coil and powers it up. Now, just a little tip on heat pumps. When dealing with rud, ream, and barred, those normally default to cooling. What do I mean by that? You actually have to energize the reversing valve to get heating on those three brands. And you normally put it on the V, on the back base of the thermostat. But most systems, they default to heating, meaning you gotta send 24 volts to the reversing valve to get cooling. But you also have some carrier units now that I personally have worked on where you don't even have an O anymore. You have a W1. So when you send 24 volts to Y, it's cooling. When it sends 24 volts to W1, it's heating. And it does that because the unit already knows, hey, I'm getting 24 volts on W1. You already know what to do with the reversing valve. We need heating. It already does everything internally. So just kind of be mindful of the unit that you're working on. Read the manual. The manual will give you more information. But as you can see, heat pumps can be fun to work on. They're not that bad when it comes to troubleshooting. They do not have to be intimidating. I hope this video helps, and I'll catch you on the next one.